third thing is we need to find a better proxy from the geo archives. So many archives available in our part of the world, but some are good, some are bad. Such archives like peat archives, pluvial archives, marine sediment archives, or aeoline archives, lake sediment archives, tearing archives, speleothem archives, and coral and ice sheets. Something like that. They are the geophysical proxies. So major important line, as I mentioned now, proxy, like chronometer, it is needed to measure time, and then we need to find the better place for finding proxy. So in general, all the paleoclimate science, most of the people who are working with the paleoclimate, they use a number of proxies, multiple proxies. Like pollen and spores is a common proxy for many people use for paleoclimate studies. They are organic wall microfossil proxy, mainly from flowering plants and non-flowering plants, fungi like lower plants, and some other algae. They also produce spores. So it is a proxy of plants and pollen and spore science. And another organic wall proxy, mostly common, the people commonly used for climate recordings, foraminifera and dinoflagellates and amoeboid cysts, which are also very good proxy for understanding past climate. And another important proxy is silicate fossils, which include two main things like phytoliths and the diatoms. Phytolith is also silicate fossil, microsilicate fossil, produced. Diatom is also living one-cell organisms, unicellular organism in the water systems. Another important proxy is most people use grain size distribution of mineralogy, mineralogical changes and magnetic property of the sediment, plant macrofossils and their composition. A lot of people use isotope composition like oxygen, carbon, hydrogen, nitrogen, and many isotopes. And this kind of compositions variations from organic matter and carbon nitrogen ratio and total nitrogen, total carbon, total carbon content of sediment. These are also another important proxy when we coming into when we work with the paleoclimate science. And also some people use chironomids like insect fossil, insect larva fossils, which is not common in the tropics, but in temperate areas and high latitude areas, which is a very good proxy. Chironomids or chironomids larva is an insect fossil, and lichen also excellent fossil to record paleoclimate. Molecular proxies in the modern world, people they use quite a lot for understanding past climate, like lipid, ancient DNA, long-term hydrocarbon compound like alcohol, acid, and wax-like things, and specific mineral also like gypsum, which is also important proxy for climate change because it's preserved. Form under the extreme conditions of environmental context. So that is the usual proxy. Then it's just to better to highlight why paleoclimate need. Mostly we are talking in the Indian subcontinent. Sri Lanka and India is a main part of this continent, including other countries. In the subcontinent, the climate is largely change in the monsoon system. We have a southwest monsoon, northeast monsoon in Sri Lanka, usually called Indian monsoons, which is largely influenced in this area. Both countries like India and Sri Lanka experiencing a rapid economic growth are increasingly vulnerable to the monsoon changes, which has happened very recently, quite a heavy monsoon and monsoon associated things which make a huge impact on our area. And it is extremely important to understand how the monsoon has been working past. What we do not know, and we certainly know some about, but we need a greater details of how the monsoon system has been worked in the past, and also it will give us some very better understanding of the anticipated changes. That's why we are looking at past climate. The past climate is a key to present and future climate modeling and understanding of climate changes in the past. So now I would happy to come to my experience in Sri Lanka, what I did in Sri Lanka for paleoclimate science. Sri Lanka is in tiny island in the Indian Ocean, everyone know, in the southern tip of the India. So the situation is in small island in the Indian Ocean, which received quite heavy rainfall from southwest monsoon, which is in summer monsoons. The location itself is very important for understanding paleoclimate, just because there is no other island in the southern part. It's directly will come and link or attach to the central Sri Lanka and other part of Sri Lanka, and passing other direction. Anyway, the southwest monsoon or Indian summer monsoon, we call it, it's a main factor what we receive very high rainfall in this part of the world. So our work, mainly the work what we did in paleoclimate studies in central Sri Lanka. Central Sri Lanka is about 2,300 meters above sea level, which is high ground, very high ground. I would say this area is very much isolated, surrounding by hills and a lot of hill range and some other lands. The area is usually characterized by the rolling landscape and forested hilltops, grassy slopes, and precipices. Many diverse pattern of this area. Actually, the area I would happy to say is like a black box which contains a lot of information about the past. This isolated landscape, we call it this area called Houghton Plain, which is one of the Houghton Plain, the area which is one of the national park which is located in this area. This is very much isolated by high ground, 2,600 meters above sea level, which make a very great high valuable archives to contain a number of proxies. So that what we are working now, this area is consists of a lot of forest, mainly upper montane rainforest, and instead of that, grasslands also dominated, wet grasslands and dry grasslands, different type grasses growing on there. Certainly, some grasses are very much wet grasslands, and some are dry grasslands, and montane forest is so common. And these are the common taxa there. Most of the taxa are endemic to this forest, and a lot of endemic forests, like endemic species, endemic trees, shrubs and herbs, more than 40%, 60% plant growing there, which are endemic to Sri Lanka. Of course, another important factor in this area is very fascinating geology and very fascinating hydrological systems. In the present day, a lot of ponds like Baker holes like these things, and some water stagnating area, which is common in this part of this world, and of course in the Houghton Plain also contain a lot of this kind of information. So most important things, what I would happy to tell our younger scientists. So this kind of archives, which contain here a lot of peat and some sediment. The lower part of this archives, which contain fine-grained silt and fine-grained sand-like sediment, and top of that, a lot of peat growing there. So the peat archives and sedimentary archives is very well preserved there. That's why we are using these archives for paleoclimate soils, paleoclimate studies. So this archives is ideal geoarchives, which has been used to develop our well-dated multi-proxy archives for paleoclimate studies. Is well coupled for geophysical settings. Surrounding area is a lot of hills and is very much isolated, and the disturbance is very minimal, and the forest growing there is very much protected area, highly protected area, so there is no disturbances going, and we can easily find out the better high resolution archives and well preserved sediments there. So now the important thing is third important point is the how we obtain the core there. We use two different techniques there. One is the jackhammer machine to obtain the long core. Another one is the Russian peat core. It's the usual one. These two techniques we applied in this area to find out a better core, how to work there with this core. So we obtained a number of cores there. So we did a lot of coring experiments there. It's an extensive coring project.